Now that you've learned about command line interaction, let's use it to improve our target heart rate program. Here's the problem statement again. To get the maximum benefit from exercise, your heart rate needs to be increased. There's a formula that's widely used. Subtract your age from 220, and your target heart rate should be between 65 and 85% of this value. And we need to remember that people count their pulse, usually, for only 10 seconds. Recall that we had some chosen variables. We had age, which was an integer. We had our weird constant that was also an integer. A double for low percent and high percent. A double for 10 seconds. Now, at the time, we actually said 1.666667, but remember, we didn't know how to divide then. One thing I want you to notice is that I divided 10.0 by 60.0. I didn't divide 10 by 60. When you divide 10 by 60, you get 0, because 10 and 60 are both integers. So even though it's a fractional part, remember it gets truncated to 0. So we definitely want 10.0 divided by 60.0. And we had a string called first name. Now, if we're going to write a program for this, the first thing we need to do is to create a class. There are 4 basic pieces to this. We open Eclipse, create a new project, then create a new class, and create a main program. So let's go and do that. Here's Eclipse opening up. Here's the workspace. Next, we create a new project. So that's File, New, Java Project. Let's call this Target Heart Rate Iteration 2. You'll notice that our project appeared here in the Package Explorer. Now you can turn the Package Explorer on and off if you wish. For example, if you like to have more space on your screen, sometimes it helps to not have the Package Explorer showing. That's controlled under Window, Package Explorer. So that's how you'd get it back if you decided to get rid of it with the little X. For right now, it's kind of nice to have it around. I'm going to click on the source directory in my project because that's where I want my Java files to be saved. The little green bullseye here is how you create a new Java class. You can also do it from the File menu if you wish to. File, New, and then Class. But the green target's quicker. I'm going to call my class Target Heart Rate. Now, we do want to have a main program in our class, and so I've checked the box here. The box is checked by default, by the way. Do remember that you need to know how to create a main program on your own, so you probably want to wait a little while before checking this box. In fact, let's uncheck it and I'll create it with you. So here's our class. Now, Eclipse and I don't agree on where curly braces belong. I like my curly braces to line up on the left-hand side. Eclipse likes them in the other place. I don't really care which way you do it. There are certainly good programmers who are members of both camps. Let's create a main program. Public, static, void, main, string, square brackets, args. Now, unfortunately, this isn't going to make any sense at this point. It's kind of a magic incantation that keeps your program running. But what the computer does is it finds the main program and it executes the instructions in them one instruction at a time. The next thing we should do is design the program. Now, sometimes people get so excited to be programming, they forget to actually think about what they're doing first. And I like to do that. I found that it saves me a lot of time in the long run. So we're going to use comments to describe what the program should do. Now, virtually all of our programs are going to do the same thing now. They're going to get input from the user, perform some calculation, and show output to the user. So let's implement this one step at a time. The first thing we'll implement is getting input from the user. We'll do that after we put comments in our code. So here's Eclipse. The input we need from the user is their age and their name. So that will be what our comment is. Notice that Eclipse makes comments green by default. So that's one of the ways you can tell when something's in a comment. Calculate the user's heart rate, minimum and maximum, and show the target heart rates to the user. So those are our comments that give some structure to our program. To actually get the input from the user, we need to construct a scanner object. And remember that age is an integer, so we'll get it using nextInt, and name is a string, and we'll get it using nextLine. In Eclipse, our scanner object usually goes right at the start of the main program. We can call it whatever we want. I often call mine keyboard, but not always. Scanner keyboard equals new scanner of system.in, semicolon after it, of course. Now you'll notice Eclipse isn't happy right now. It has a little red line under scanner. This is because we have not told Eclipse where to find the scanner class. To tell it that, we say import java.util.scanner. And now Eclipse is happy again. Well, actually it's only kind of happy. Notice it does have a little yellow warning. Now, you don't actually have to pay attention to yellow warnings, but sometimes they have valuable information, so it's not a bad idea. In this case, what we're being warned about is the fact that we haven't used the keyboard to do anything. Eclipse worries about that because that tends to be a mistake. So now we're going to get the user's name and age. Remember, the name was a string and the age was an int. When we get input from users, we always have to prompt them and tell them what to enter. So let's do that. To prompt the user, you use system.out.println, and we'll say, enter your age. So age is keyboard, which is the name of our scanner object, .nextInt. The next thing we want to get is the person's name. System.out.println, enter your name. So name equals keyboard dot next line. Now the reason we're using next line there is that people's names can have more than one part. You could have a first name and a middle name and a last name, for example. And this will get all those different parts. Particularly when you're new to programming, it's a good idea to echo your input. So let's do that. So your name is, and this is in a system.out.println statement, name, and system.out.println, your age is plus age. We're now ready to run our program. Running a program goes with a little arrow key up here. You can also call it from a menu if you want. It's the Run menu. Right here, it's the first choice in it. But I find the little arrow to be much more convenient. So we're going to enter your age. I'm going to lie egregiously and say that I'm 19. And oh my goodness, our program did something wrong. Notice it didn't wait to get my name. And now it says my name is blank and my age is 19. So the age is being entered all right, but the name isn't. Now, let me be honest. Normally you enter the name first and the age, and the reason I did it in this order was to show you this problem, because it's a very common problem to have come up. What's happened here is after we entered 19, we hit the carriage return. That probably looks like an enter on your keyboard. The next line method reads that carriage return as the next character to be read. And as a result, it doesn't have a name at all. The name is empty at this point. So we have to do this a little bit differently. To fix this problem, what we do is explicitly read in the carriage return right after the integer. That way, when the name is entered, it will be on the next line and will be read in properly. Let's run our program again. The age is 19. The name, Deborah. Name is Deborah, age is 19. I think you can see some of the advantages of working on programs a little bit at a time now. If we hadn't done this work, if we hadn't printed things out, we wouldn't know that we had made that mistake until much later. It is much easier to debug 3 lines of code than it is to debug 10 lines of code. So our strategy is going to be check early and check often. We wanted to make sure the input's working, and now it is. Here's another explanation of what happened in our code. When the program prompted enter your age, I entered 19 and then the entered key. It then prompted enter your first name, and I entered Deborah in the enter key. The 19 was read by the next int, and the enter was originally read by the next line. We fixed it by reading the enter by the next line and then using another next line statement to get the name. Let's recall the math. Let's say you're 19. 220 minus 19 is 201. 201 times 65 divided by 100 is 130.65. 201 times 85 divided by 100 is 170.85. So your target heart rate would be between 131 and 171 beats per minute. This means your 10-second pulse would be between 130.65 times 10 divided by 60, which is 21.83, and 170.85 times 10 divided by 60, which is 28.5. Now remember, this slide is written in math, not Java, so we're not thinking about things like integer division versus double division. Let's create this calculation. Now we want to perform and check one step at a time, and we want to be very careful about the differences between double and int. Remember that these do not work the same in computer science that they do in math. Division is particularly troublesome, so it always pays to take an extra second to consider division when you're writing code. Now we had some constants. We had crazy constant, which equaled 220. We had double, low, percent, which equaled 0.65. Now that 0 actually isn't required there, but I like to put it in when I have doubles to make it very clear that I'm dealing with a double. Periods can be very small on the screen, and so it helps to put the 0 there so you can see that there's a period more easily. Then we'll have final double, high percent is 0.85. So the first thing we did is we have our value, which we're going to call an int, which is crazy constant minus age. Now the parentheses there are not necessary, and in fact I'm not sure they're helpful, so I'm going to take them out. Now we'll have a double, which I'll call low heart rate, and that's going to equal value times low percent. and we'll have a double called high heart rate, and it will equal value times high percent. Looking at the code here, I see that I forgot a space before low percent. It doesn't actually matter to how the code works, but on the other hand, you want to keep your code as beautiful as you possibly can. It's very well worth the time you spend beautifying code. Now these are doubles, and we need to change them to 10-second heart rates before we can print them out. It might not be a bad idea to print them out right now just to make sure that everything's going okay. So let's do system out print line low is plus low heart rate, and system out print line high is, and then high heart rate. We probably aren't going to keep this in the program permanently. We're just doing it to check as we go along. This is the write a little, compile a little, test a little strategy. So when we run again, we'll see enter your age, which I will once again set at 19, very falsely. And we see we're between 130.65 and 170.85. So it looks like everything's going just fine. So let's get rid of those. We might also get rid of the your name is Deborah and your age is 18, because those were also just debugging code. Now there are some people that like to just comment things like that out, and sometimes that can be a good idea. I think it tends to make the code look messy though, and so I don't like it. I like my code to be clean and easy to read. Now we need to change to a 10-second heart rate. So we had a final, which is a double, and we called it something like 10 seconds. And it equals 10.0 divided by 60.0. Remember, we put the point zeros in there to keep this as a double division. If we made it an integer, it would be 0, and that would not be helpful. Now, when people count heart rates, they usually count an integral number of beats per 10 seconds. They don't count 10 1/3 beats, and in fact, it's very hard to do that. So we're going to have to think about how we're going to get our 10-second heartbeats. Let's do int 10-second low equals, well, we're going to take our low heart rate and multiply by 10 seconds. Now, you can see Eclipse isn't happy because it has a red line under low heart rate times 10 seconds. The reason it's unhappy is because of the types. Low heart rate is a double, and 10 seconds is a double. When we multiply two doubles together, we get a double. And we're trying to store a double in an integer variable. That doesn't work. Java can't figure out whether you want to round or anything like that on its own. You have to give it very explicit instructions. So what we're going to do is round. So we're going to add 0.5 and then truncate. Now the way you truncate in Java is with an integer cast. Probably a good idea for us to print this out right now. We can perfect it later. Just to make sure our program is going in the right direction before we make the same mistake twice. Age is 19, still Deborah, and our low is 22. And by the way, in that code, I made one of the classic mistakes that programmers make a lot. I forgot to put a space before low. It's also not very well written, but we were just testing code, so it doesn't matter so much. Since that answer we know is correct, we can now do the same thing with the high heart rate. So we'll have an int, which I'll call 10-second high, equals, and the code will be just exactly the same. In fact, you could cut and paste it if you wanted to. We'll learn other methods for rounding as we go along. So now, let's write some output for our user. Your heart should beat between, I'll remember my space this time, 10-second low, space, and space, plus 10-second high, in 10 seconds. And now we're ready to run our program for the last time. Well, maybe it'll be the last time. It's only the last time if we get the answer right. Once again, 19. Still Deborah. Your heart should beat between 22 and 28 in 10 seconds. Well, that doesn't look very pretty. So much for it being the last time. So let's put times in 10 seconds and run the program again. It's important that you always rerun the program even when you think you made a change that isn't going to matter, because it's so easy to make little mistakes. Your heart should beat between 22 and 28 times in 10 seconds. That looks good. So we've shown our output. We made sure that our output was spelled properly and that the spacing was attractive. Things like that are part of professionalism and are very important to computer scientists.